Yes, so I'm Robert. I work for the RIPE-NCC. I have been working for the RIPE-NCC for a long time. I was dealing with research and development activities, including RIPE Atlas. Nowadays, I do mostly measurements and still doing Atlas. How many of you have been at the RIPE meeting 2 weeks ago or 3? Quite a number of them. So you may have heard what I'm going to say, at least a part of it. How many of you are actually using Atlas? How many don't know what it is? At least one person. Good. So then I will talk to you, fine? The others are just coming along. All right. So the RIPE Atlas, the reason why I'm saying this all is because I'm going to mention things that you may not be aware of, and I guess if you are aware of it, you might actually be happier to actually use it, because it's good for you. So at the end of the day, it's an active internet measurement network, and here I would like to emphasize that it's active. So that means that we are not listening to any kind of traffic that's just flying by. All of these devices are actively reaching out, sending DNS packets, ping packets, traceroute, NTP, and all kinds of stuff, and then collecting the results, storing them, and giving that back to the world as an open data set. So that's important. It is built by the NCC, and we are still operating it, but we cannot do it alone, so we are relying on community members such as you to actually host those end devices, the vantage points, which we call probes. Okay? And this allows us to basically, at least in theory, be present everywhere on the internet. In practice, that's never going to happen, that's fine, but at least it's a nice target. It's been operating for 14 years or so. It was launched in 2010 at the Rome RIPE meeting. And that speaks for the stability which can be provided by the RIPE-NCC via the members, which are basically you, as opposed to a measurement network that is built by a research institution, and then when the PhD is done, then the operator just leaves and then it withers and dies. So it kind of doesn't guarantee the stability that is going to be there, but at least that's the idea. We have worldwide presence. About 2/3 or so of the devices are in the RIPE-NCC region, so that's Europe, Middle East, and parts of Central Asia. But we cover basically all continents, and as far as I know, we even have one probe in Antarctica, or at least we had one at some point. But everyone wants to use that, so it's basically just on fire all the time. The reason why we built this is to support network operators such as you. You don't need RIPE Atlas to run your network, that's not the point. But if you can use it, and you know why it is for, why you actually jumped on, most of you did, then it can support your operations, so especially if you hear questions about, oh, something is wrong, someone tells me over there that they can't reach me, then the system is there for you to actually look into that. But we also support researchers and other users in understanding the state of the internet via this. All right, so that's too much. No, not too much, fine. Concepts. We have the probes, so those are the vantage points. At the moment, we have a bit over 8,000 hardware devices. And I suspect that many of you have the different versions. There was the original one, which looks like a tiny black mouse. There's the white one, and then the next generations. Because we started building it 14 years ago, obviously the technology was different, so we had to go through various technologies over there. We also have software probes. So there was a demand that, hey, I don't want to, or I cannot plug in a black box into my network. But I'm willing to join, so is there a software version? And there is. It runs on multiple Linuxes. It doesn't run on other operating systems. Sorry about that. But if you want to install one and you cannot get a hardware probe because there is no supply or it's not possible on your network, you can still use any lying hardware or your existing hardware that you have, or a VM. It's really, really your choice. We also have the anchors. These are originally rack-mounted PCs. Nowadays, you can get them in a VM format as well, but the idea is that they should be in the core network. So these are more representative of the core, whereas the probes are more about on the edge. Anchors are mentioned again because if and when you install an anchor, it's not only a probe, but it also acts as a willing target for measurement traffic. And as such, it's immediately involved into a full anchor mesh. So at the moment, we have 800 or so. If you start an anchor tomorrow, 800 other anchors will immediately traceroute and ping to you, giving you a constant stream of data about how the world sees you. So that's kind of a really nice benefit. Hosts. Hosts are the people who are owning these hardware or software packages, basically. So those are the ones who accumulate the credits, which come on later on. Maybe that's useful to mention. So credits is basically what you get as a token of appreciation when you run such a device. And that you can spend on doing your own measurements if you want. So the system does whatever it does because others are active, but you can be active as well. You can measure your own things. The two different major kinds of measurements. One is the one-off, which basically means I want to measure this thing right now and give me the answer immediately. You can use any probe you want in the network. So for example, you can say, ping me from 100 different hosts in North America, and then collect all those results and give it back to me. And we have nice visualizations for that and all of that stuff. The reaction time is measured in seconds. So on average, for a ping measurement, we give back all the results, well, like P90, so 90% of the results within 10 seconds. And they're all on the map. So this is very informative. Periodic measurements are ongoing. So that's kind of collecting the baseline or knowing if things are normal over time. And for those, we give you graphs if you want, but also maps, and there are all kinds of other stuff. But the intention there is that you can start it up, it's running, and if you want to go back to it to understand what happened at any point in time, you can. The data is available publicly, everyone can use it. Researchers love that because they can observe a whole bunch of stuff. But also interesting network events such as country shutdowns and so on are very visible in the data set because it's public data. Ambassadors help the system by taking on the job of local probe distribution. So for example, we have someone in Colombia and he knows those networking people over there. We ship some probes to them, to this guy, and then he's giving them out and convincing people that this is actually a good thing. And then last but not least, sponsors is a very interesting and important concept for us because it's, you know, running this network is not cheap. So we are appreciating others, entities who step up, not just the members, but for example, this year ICANN is a sponsor because they get a lot of data about the root server behavior. If you didn't know, you are there. In Finland, at the moment, we have 122, I think, probes up and running, including anchors. So that's nice. What we're doing right now, as you can imagine, we've been collecting this data for 14 years. That's a lot of data. On average day, we collect about 1 billion results. And well, it's, you know, has been increasing from 0 to 1 billion nowadays linearly, but you can imagine that's a lot of data that we need to store. And we don't know in advance what kind of value it will provide a year later on, because someone might see, oh, that was a signal, and I can prove it that something was happening over there. So we want to keep that data as long as possible. We are moving that data set off of our on-prem network because running a HBase cluster for this size is very expensive, so we're simplifying operations and saving costs in there while keeping the data available to people. So if you want to download your data from a couple of years ago, it's still available. You can get there, but on a different technology, so to speak. Then, infrastructure. So, as you can imagine, we have to maintain this infrastructure. Nowadays, the operations people are very happy if we run it in a containerized environment, Kubernetes and all of those beautiful things, auto-scaling up and down, as you can imagine. We have to do that because otherwise managing this with the same resources is quite hard. We are on track on this one, and it's going to finish relatively soon. One of my favorites is the user interface, because at the end of the day, the machine is humming, but if you don't have a good access to it and it's a nice interface, then there's no point, right? So we are renewing the user interface, and we're doing it function by function, so to speak. Just before the RIPE meeting, we released new measurement pages, dashboard, promotional pages. If you know nothing about RIPE Atlas, there is a beautiful set of pages that tells you what you can do with it, what the benefits are, and so on and so forth. We started working on the probe status pages, and then everything else is coming. I have laser, yay. Well, I would like to emphasize this one. So this is the old measurement interface. This is the new one. You don't necessarily see the difference right here, right now. But one thing that was in the APIs for a long time, and now it's exposed to the UIs as well, is that you can manage what probes are inside your measurement. So you can imagine if you started a measurement 10 years ago, some of those probes died in the meantime. So we had an API to remove those and add new ones, but it was kind of clumsy to use it via the API. Now there's a one-button feature that says just drop the old ones. They're not useful. And you can add some more probes That's kind of useful. But then new visualizations, time travel actually now works really well. You can go back in time and say, how did it look, you know, a day ago, or a year ago, and so on. The visualizations work exactly the same way. All right. The software probe, as I said, it runs on Linux, multiple versions, so Debian and Red Hat and so on. But because it was built like 14 years ago, or started building 14 years ago, we could get away with a lot of shortcuts, so to speak. So it could run as root in all the environments, because that was the only thing that ran in that environment on the hardware probe. That's no longer true, so we are working on properly packaging this up, so you can just say apt install bang, and then you're done with it, basically. At the moment, we're working on Red Hat-ish releases, so that includes Oracle and Rocky Linux, and take your favorite version of that. And the next one is probably going to be Debian and then OpenWRT. And then all kinds of variations like Docker and Raspberry are possible already, but as I said, we're trying to make that easier for people. Now, time doesn't stand still. The system needs to evolve, and there are a couple of triggers for us to change the behavior, so to speak. Sometimes that comes internally, sometimes we get notified from people that, hey, we observe this behavior and we like it or we don't like it, so do more of it or do much less of it. One of those things was that someone spotted a particular host who ran 150 probes, virtual probes, so software basically. And then the question was, why would you do that? So people claimed that this is basically just credit farming. So the only reason to do this is to get more credits so that you can sell it or use it for your own measurements, which is kind of not useful for the system, especially not for the people who pay for it. So we have been asked, look into this, and we did. And actually, it turns out that this particular user is doing this because they can get more credits. So we're trying to channel that person into being a sponsor or run anchors and stuff like that. But in the meantime, we are basically putting in restrictions such that you cannot have more than some number of probes on the same IP address or on the same network, because it's not useful for anyone. It just costs, but the benefits are only manifesting on a single person. So that's, for a community, it's not useful. Measurement aggregators. There are some institutions out there who like to collect requests from their clients and channel those to Atlas to say, hey, my client wanted to ping that server. And Atlas can do that, that's totally fine, except that we don't know if this happens on a large scale. We don't know how many users are actually using the client. We only see the aggregators, right? And this is happening for commercial reasons and for non-profit reasons, all kinds of stuff. It's all fine, but we wanted to know, well, we got this trigger that is useful for us to know, and we also wanted to know how prevalent this is. So we are going to add the feature where if you want to do this, you have your own clients, that's fine, you can still keep on doing this, but we would like to get an indication of how many different clients are using the system, right? Because then we actually know if it's 10 or 1 million users. Otherwise, we will only see the aggregators. That's kind of a biased view on things. Data retention, we, as I said, are storing this data for a long time, but we have to do it in a financially sustainable way. We are not wasting members' money on that one. So we put out a proposal that says we are going to look at these principles when we store and retrieve and make data available, to see what people think about that. All right, then there were other proposals before, and some of you might be interested in some of these, so I figured that it's nice to keep this slide from the right meeting. Never mind the first one, very, very detailed. If you're really interested, I can point you to the discussion. That was just a technical issue. More to the point, we had heard a whole bunch of members and users who said, wouldn't it be nice if CDNs were measured by Atlas? So Atlas is intended to be a network-level monitoring tool, but depending on your definition what the network is, CDNs do fit or don't fit. But the reality is that an average internet user, when they surf the web, when they use the web or the internet in general, they usually, for 90% of the time, are talking to the top CDN providers. So having an understanding, that's just a fact, but having an understanding of how they reach those CDNs, is that optimal, where the improvement points are, if there is breakage, is that specific to a particular user, or is that specific to an ISP or maybe even a country, is useful knowledge. So imagine if we had such a thing, then a random user can look at their probe page and then it will say, yeah, you can get to Google, no problem, and everyone else in your country can, so that's also fine. Versus, yeah, your ISP doesn't provide access to Meta today, every other ISP does. Maybe a difference over v4 or over v6. So the user, and the host in this case, is much better informed. Excuse me. So we're not going to do the full deployment because there were voices against the proposal, but we're going to do an experiment to see what kind of value would it bring to host if we actually did this. Generic HTTP measurements, again, people were asking, hey, I run a web server, can I use RIPE Atlas to measure connectivity there? And there are a lot of caveats with this, because at the end of the day, these probes are in home networks and in weird places all over the internet, and accessing just any kind of random content could lead to problems. So we were looking at how this can be done safely, and it's really, really a hard problem. If you want to know the details, we can talk in the sauna about that. But at the moment, we're not going to implement generic HTTP measurements. That's the bottom line. There's only a very few ways to do it safely, and that doesn't fit the model that we have. Start TLS. We have been doing TLS measurements from day 2, maybe not day 1. Meaning that you can get to a server which runs TLS, and the system just got the certificate out of that. So this was nice to observe if different certificates are visible in different parts of the world, if someone wants to fake access to Google, for example, or whoever else, you could do that. The argument was that we should do something similar for Start TLS, because your expectation is that if you're talking to the same mail server, you will get the same certificate. But if those probes want to talk to that server, they get a different one. That's kind of weird, and you want to know if that happens. And finally, we have what we call non-public measurements. By default, all the measurements are public, and there are reasons for people not to do that. For example, upcoming infrastructure, you don't want to tell the world because first you want to test it, and Atlas is perfect for testing, right? So that's the intention. And in that case, you want the system to not publish those results. But for this means that we're only keeping that data available for a short time, because it's, at the end of the day, it's not used for anyone else if it's not public. So therefore, we are not spending money on keeping that data for years and years and years, because even you are not going to look at it even if you used it. All right, and then there are a whole bunch of topics that I can talk about to entice you to use it more. If you happen to have credits because you use you have installed the probe a long time ago, I encourage you to actually do stuff, because then it's really useful. If you're just accumulating credits, then the usefulness doesn't materialize. We have a whole bunch of APIs. You can interact with the system. You can search for probes, measurements, all the results, anything like that. Very extensive. And the new user interface is also using that. So we are really standing behind those APIs. There are a bunch of tools. We've heard people saying, user interface is nice, but I'm a terminal guy, so help me. So there are multiple versions. Yours truly built one in Golang. To interact with the system, with the one-liner, you can just say, RIPE Atlas, ping me, done. And within 10 seconds, you get the results back. So this kind of stuff is possible. We have Python implementations and some others as well. Two tools that I wanted to highlight, LatencyMon and TraceMon, which are not well known, but I think they should be because they're really cool. And they're somewhat left behind in the UI, so we're trying to renew them. But LatencyMon is one where you can imagine, the name suggests you can monitor latency. So if you have a measurement or someone has a measurement, it doesn't even have to be yours. Then this visualization can aggregate probes in ASNs and countries and draw lines about how they saw the target over time. And you can see correlated behavior. If there's a network problem somewhere, then LatencyMon can let you zoom in, zoom out, and all kinds of stuff. It even has continuous monitoring, so if you press the right button, then it just, the thing just shifts over time as new data comes in. The intention was to put this on a NOC wall, measure yourself, and then stuff just appears on the screen. TraceMon, I love it. If you do traceroute measurements, say 100 probes to your network from all over the world, TraceMon can give you a graph about how those traces converge on you. Well, on the target in general, but supposedly you, if you are the target. And then it can annotate that with AES numbers and IP addresses and names and all of that stuff. And this is highly useful, especially if you hear that, oh, there's a choke point, someone cannot get to me. So you ask those probes and you see that, well, those guys who come from the right converge on this point and they don't get any further. But anyone else from the left, they get to me. So this is kind of the intention. Imagine a graph towards this central point. Big data or not, data analysis. If you're interested or you have friends who want to do PhDs or masters, we have a lot of data available. We have daily dumps of the public data going back a month, so you can just fetch everything you want. It's a couple of terabytes, I guess, every day. But there is signal in that. Just an example, some researcher in the US got a master's degree analyzing how German ISPs disconnect their users every day. And because and give them a different prefix, of course, and supposedly to prevent them from running servers on their home network. Fine, they probably have reasons, but the point is that the data was in the system, and we published the connection, disconnection metadata, and this was very visible. They can group it in ASNs, and look, and lo and behold, fine. On V40, you get a different prefix. On V6, you were stable. Stuff. For the moment, we also have the data in BigQuery, going back, I think, 3 months or so. If BigQuery is a thing that you know and like, it's really, really, really handy to dig into large volumes of data. And we also have DNSMon and DomainMon. DNSMon, if you're in the DNS business and that you're relatively high up in the food chain, you run a TLD, hello, that could be highly useful. It's basically monitoring those zones. So the root zone and something like 50 or 60 or so TLDs from 50 or 60, 70 vantage points. And then you can see a nice chart that says, these were vantage points that did have problems or correlated behavior and that kind of stuff. Same thing for DomainMon, except that you can run it for yourself. So the same visualization and everything else is the same, or clone of DNSMon, but basically if you have a DNS domain, which you do because you run a network, you can monitor that DNS from any probes you want, but the difference between the two is that you pay for that yourself by your own credits, right? So you can say, well, it's fine if 10 probes are involved, or no, I want 100, or whatever it is, and the visualization is there. And then IP map is a kind of something that we don't have enough energy to really enhance, but the idea is to do infrastructure level geolocation. Like, where do the packets actually go when they get from A to B? The commercial IP geolocation providers are really focusing on the eyeballs, where the clients are, right? Because credit card processing and all of that and content delivery needs that. So they don't really care about whether the packets go left or right. We do, so there's that. So I just wanted to give you an overview of what we have and maybe highlighted some features that you could be interested in. You can find me around. And we have, I guess, some time for questions. There's one.
So we have questions. How many? We've got 2. Yeah. Do you want to do your next talk after this? Well, we've got 20 minutes.
I'm happy to answer questions. The rest needs more beer.
Hi, Esa, Olli Teru from Tieto Velhot. And my question is, there was a mention about the software probe, but have you been planning to make a container type?
Yeah. Yes and no. We only have so much energy to maintain, 3, 4, n different distributions. And I know that one of my colleagues actually made it work in Docker, which is kind of trivial. but we didn't officially publish it. We don't stand behind a Docker instance that says this is the official Docker instance. It's entirely possible. It's actually relatively easy.
I run one in Docker.
Well, there you go.
We are running as well.
So this is, I think, the community edition. Like, you need to talk to those people. It's definitely possible, and it just works. What I do know, though, however, is Docker has some problems with v6. Let's just put it lightly. It's that part is not trivial. Maybe if you guys solve it, then I would like to hear it as well.
Only interested in V4.
Who cares about v6? Jen does, I know.
Was there another question from the back? Do you want to come forward?
So I just saw it quickly.
Well, no, because
there's a stream. So
we're broadcasting.
Please use the mic.
So it's not for the people in the room, it's for the people elsewhere.
No, this is inclusiveness in action.
Hello, Pekka from North. Just generic question. You have been collecting data for 10 years. Has there been some outcomes of that collection? And then a second question, is it pseudonymized or anonymized, or how do you call it?
Pseudo-anonymized, yes. Okay, very good questions. Let me answer the second one. The short answer is no. We are very careful about how we handle PII and so on. So basically, if you say, I'm fine with this and I want to make my probe public, then I accept the fact that my IP address will appear in results. That's part of the game. If you don't like that, that's... But to answer your first one, yes, I have so many war stories to tell you, which we can do over Sona, I guess. Just let me highlight one or two that comes to my mind. A couple of years ago, all the probes in Turkey, or like 90% of them, when you look at how they reach the root zone and when they want to look up Google results, so they use 8888 or stuff like that, you expect lines going flat because latency is what it is. But all of a sudden, correlated behavior in Turkey showed that all those lines started to wiggle left and right. And then we looked at the results, and it turns out that, yeah, it's not like Google instantly popped name servers in Turkey like 5.5 milliseconds away from the probes. They were just lying, right? And in other cases, we see country shutdowns. The beauty of the probes is that they still operate and they do what they were told, even if they are disconnected from the infrastructure. So in some sense, we see how the world is visible from inside an outage, right? Every other network is trying to get there and say, ooh, where do packets end, and so on. But we collect the data from the inside, and inevitably these things connect back to the network, and they report this is what we saw from the inside, right? If they never connect back, that's a different story. That happens as well. It's a different problem space, I guess. But once they do, we see these kind of things. We see all kinds of issues of DNS zones expiring and people scrambling to fix that, connectivity problems and all that kind of stuff. I can share you war stories if you want.